Your life.
All right, perfect. All right. Hey everyone, welcome to our live stream of EigenCloud and Recall. And today we're very excited to chat about AI agents and some of the problems that AI agents have, like how they can maybe steal your money and how you can't necessarily trust them even if they can't steal all of your money, right? They can still make a lot of decisions that you don't want. And so our topic today is to talk through like where some of the trust gaps in AI come from and like how users can start to really understand and trust these AI agents that are going to be making a lot of decisions on their behalf, right? Like if AI agents are deciding whether we get an insurance claim or investing our money, like we as the user have a right to know like how it's doing that, why it's doing that, and how. And so we're gonna dive into that. I think before we get started, Andrew, do you want to just briefly introduce all the great work you're doing with Recall and
Yeah,
agents in general?
yeah, absolutely. So first of all, thanks for having me. Really excited to chat about all of this. Um, I'll try to put it kind of in one line, and then I'm sure that we'll unpack it in 100 different ways later. But yeah, I'm Andrew, CEO at Recall Labs. We're building the Recall network. We run arenas where communities and organizations can fund skills that matter to them, and agents can compete to show how capable they are at achieving those skills. Right now, if you go to the Recall Network homepage, you'll see a lot of skills focused around the crypto trading domain. But there's sort of a lot of different skills that we're planning on unfolding, and we can talk about how and why we'll do that in later parts of the call.
Awesome. Well, thank you so much for being here. And Andrew, I don't know if you mentioned, but you're the CEO of Recall, right?
Yep.
Okay, perfect. And I'm the GM of EigenCompute. I'll be the host for this live stream. And Shriram, do you want to just briefly introduce like EigenCloud and yourself?
Hey, hi everybody. Super excited to be here with Andrew and Vignesh. I'm Sriram. I'm founder of of Eigen Labs, which built EigenLayer and now EigenCloud. Um, I'm super interested in this area of how AI and crypto meet. I think I started in crypto because in 2017 I knew I was losing my job to AI. AI was beating some of the benchmarks that we were building using mathematical algorithms back at that time in genomics. So I knew that crypto and blockchains are the only things that AI agents couldn't fake. So it's kind of like a long-term bet and really amazing to see. It just a short 8 years after uh, that we are so far in general in the space and like what we are able to offer specifically from Eigen, which is trust and verifiability for these agents. So super excited to be here and do this thing. One way to think of what is EigenCloud, we call it the verifiable cloud, right? And uh, if you think of what is the value proposition of crypto's value proposition is trust and verifiability, right? So when you think of like Bitcoin, is verifiable money, right? Money that there's only 21 million coins of, you own your coin. Ethereum and later other L1s like Solana, basically verifiable finance. I want to do DeFi, I need to know like things are verifiable. But the underlying scale of compute that these blockchains can support still is very limited, right? Like the whole computation that like an L1 like Solana can support is still like one server, like a $10,000 server. But you can't even fit like a single AI agent inside these servers. So you need much, much more verifiable compute than what is offered today in crypto. And so that's our goal, EigenCloud. We want to complement existing chains and provide trust and verifiability for things which are simply not possible on chain. And so this includes, and a predominant example is things like AI agents. When you think of an agent, you have computation you need to do, you have inference you need to do, you have data that you need to store and make available. And so that's the three primitives that we built: EigenDA for data, EigenCompute for computation, EigenAI for inference. So you can mix and match them to build very powerful off-chain things, which still have very close to on-chain security. So that's our kind of long-term goal, is to enhance the set of possible computations that you can do with off-chain compute, but still get on-chain trust and verifiability.
Awesome. And I think that's actually going to kick us off into our first kind of question, which is, why does trust matter even more in the AI space today than it did maybe 8 years ago when you first started your journey, Shriram? How are you both thinking about trust in terms of like how AI, when we hire it to do jobs and it starts making these really important decisions in our lives, like how are you thinking about how people can trust AI systems now, and like how they could trust AI systems that are actually maybe built on better solutions in the future?
Yeah, sure. I can take a first stab at that and kind of answer it from our side. Yeah, I think there's a lot of reasons why trust is emerging, and but I think the broader set of verifiability is kind of emerging as a really important concept for AI right now. I think on one end, you could like put a finger on kind of the broad problem with AI right now. I really like the way one of our collaborators put it, which was basically like AI is unfolding very similar to the software engineering axiom of make it work, make it right, make it fast. And we're just still in the make it work phase. And because of that, there's like a lot of noise in the ecosystem of a lot of people trying a lot of different ways of making AI work and be economically valuable or add personal happiness or different metrics. And because of that noise, it's a lot of times very difficult to measure which are actually capable. There's just a lot of marketing. There's a lot of investment going into it. And so for us, verifiable measurements and scores and head-to-head battles and evals all are addressing that. I think if you kind of narrow in the scope, you could talk about within an organization, verification is actually a really big problem right now. So I'm sure many of your audience have kind of heard this before, but right now the AI models are incredibly capable. They're capable tasks and skills that we don't even have eyes on. The labs don't even have eyes on it. There are niche communities around the world that are getting AI to solve really, really complex and long horizon problems that are so niche that you and I just don't see it every day. But at the same time, for most of us, because of the capability of these models, they're very good at kind of the middle problem. How do you take a problem and get a result for this broad domain of problems? And so the bottlenecks are in the prompting. How do you tell it the right thing to do? And in the verification, how do you know what it did actually was what you asked it to do and that it's the right or a nearly right answer? And I think organizations, so be like looking at that bucket, organizations are getting very capable at the prompting. The whole agentic movement is very much around the prompting. These are reusable kind of software that wire together a lot of the prompting and the rules and the rails and the buffers and all of that to get the agent to do the right thing through the middle part. And then how do you verify it at the other end? And there's a lot of things we need for that. For us, we think a lot of that looks like evals. And we think we're in the kind of early days of evals where the whole ecosystem is moving and recognizing that static benchmarks can't keep up, but evolving and living and breathing evals can actually do a really good job for the broad ecosystem and for organizations. And then personally, if we kind of zero in even closer, I think personally, there's a lot of reasons why verification and trust of AI is going to be critical. Like when you're trying to make financial decisions or health decisions, or you're trying to get an agent to automate your work throughout the day, you're going to want a lot of guarantees that it's actually doing the work that you asked it, where that's happening, that leakage isn't happening, all those sorts of like security and personal interests that gets lumped into that bucket. And I think there's just a host of reasons why we want stronger guarantees about where agents and AI is running, what they're doing, what they did, and what that kind of supply chain looked like even.
Yeah, definitely. Shriram, anything you want to add on that?
Yeah, absolutely. And I think like this is a question. I think there's two parts to this. When you think about trust and verifiability for agents, you can think of two levels of verifiability. Okay, one is this action is taken by this specific model using this specific data. Like that's what we call a verifiable runtime. A runtime that this specific model is what is making these actions. That's one level of verifiability. I say, oh, it's GPT-5. What is GPT-5? Like every day it's a different GPT-5, right? It's a sycophant one day, it's like another thing another day, and if we don't need to talk about Grok. It changes its personality even faster. So the first level of trust and verifiability is this agent is actually doing it. Because when you think about humans, like the first thing that you want to establish is identity. Is this really Andrew Hill from Recall? Is this really Vignesh from Eigen? Is this, without establishing identity, this conversation is kind of like meaningless. So we want to start with establishing identity. And we have many human ways of knowing identity. The sharpest way of knowing an identity of an agent is run the agent on a verifiable runtime. You know that this specific code executed and took this action. Once you've established a verifiable runtime, you've established very rigid identity. This code, this model hash is the one taking these actions. Now you can build the next level of trust and verifiability on top, which is this agent any good? Which is really what I think Recall is making a lot of strides. So first is this agent what it is? Is this agent actually doing these actions? And that's like where the verifiable runtime comes. Is this agent any good? Is it doing what it's intending to do, what we are intending for it to do? And that's really the kind of like measure the skills, know how good it is. So both are verifiability, just at different levels, right? So it's the verifiability of the runtime and the verifiability of the capabilities. And so distinguishing this is useful and actually like also sets perfect context for why we think there is a really strong partnership here. What EigenCloud does is enforce conditions of runtime verifiability. You throw a model and say, like, here is a model code, this is what's running, this is the thing, and you're interacting with this model. It's not a thing that can be changed. Like one example quote I have in mind is Eric Schmidt talks about, imagine you want to give your kid access to a model, right? It's useful, it can be a useful teacher, so you want to give your kid access to this model. And then give kid access to this model, and then the model drifts over time and makes maybe it's more addictive to your kids. It's teaching your kids things you don't want it to teach. How do you ensure this? The minimum thing is you want to have a verifiable runtime, because then you're interacting with this specific model. You're not interacting with anything else. And so that's the first grade of problem. The second grade of problems is, is this agent actually good at what it's doing? Is it capable? Is it like following your intent? I have a ticket booking agent. Is it actually doing what I'm asking it to do? Is it booking a ticket somewhere else? Is it good at what the actions that we're asking for it to do is? In the AI world, what is normally called verifiable rewards is at this level. It's the capability level that they're talking about. But I think these two, if you think of what Ethereum did for smart contracts, is basically a verifiable runtime for EVM smart contracts. So Solana is a verifiable runtime for SVM smart contracts. And so that's really what blockchains did. What we want to do at EigenCloud is be a verifiable runtime for all agents. And that includes like computation, the inference, the data connections, this is the identity of the object that you're dealing with.
Awesome. And Andrew, I think on that note, I would love to understand more about like how Recall is helping people solve this problem, right? Because if like as an average user or an average person, I might not even know what the word eval is, right? Like you've probably already lost me. I can look at like Google reviews, I can look at Yelp, and I can use that to find restaurants, but I have no idea even like what inference maybe means, or like evals, or if you say MCP in tool calls, Shriram will start making fun of me for going two gig of brain already. So how does Recall kind of help condense this incredibly like complex space of like what an agent looks like and make it into something that people can actually understand and evaluate?
Yeah, I have this. I think you're totally right, but I do have this this dangling doubt in my mind that I feel like most kind of mid model users today are kind of like pseudo CTOs, Like I feel like the vocabulary of folks around AI is much high. Well, I know it's much higher than like databases at the peak of database, SaaS craze or whatever. People didn't know the acronyms and things, but in AI, for some reason, yeah, everybody is like a mini CTO. It seems like they're much more technical. So we have that advantage. But yeah, you're totally right. So like we think of evals as like evals are a pretty broad space, and they help with that, what I was mentioning before, that like later verification that the agent or the model did what you expected, or that it's aligned to what you wanted. And this can happen like many steps throughout a workflow, so you don't have to think about it as like a final thing is shipped and then whatever. But this is going to be a really big area of technology for the coming years because of this problem that we're kind of all getting bottlenecked by the verification step. And you can broadly think of verification breaking down in just a handful of different ways. You have like the evals that have that are looking at an objective outcome and then trying to score how the agents performed to that objective outcome. And so those don't really take a lot of sophistication to build. You can think of evals that are fully subjective, and then how you can score or actually run an eval that is like that. You can roughly break down into either you need humans in a kind of human in the loop step where humans look at the result and score it or evaluate multiple options or things like that. Or you can use AI itself, like a LLM as a judge, LLM as a scorer kinds of workflows where another model or a cohort of models can actually score results and provide those back. And we're actually aiming to address each of these. But the first area, which we thought is kind of, to your point, the most sort of simplified for a consumer audience are arenas. And what I would think of an arena as sort of like a performative eval, where agents are competing in real time or near real time to achieve an output in a way that is public so that people can view those. And we're focused on ones right now that have objective outcomes. There's other arenas that exist that have human in the loop steps. So I think a lot of people might be familiar with LM Arena, which is used to evaluate prompt responses from multiple agents. And so any user can submit a prompt response and then see multiple results and provide their pairwise judge. And you get a lot of that data. And then you can get a leaderboard, but you also get training data that you can give back to the model creators so that they can use that to make their models better where it was not right, or make it sort of sample higher where it was correctly doing things. In our current phase of working on arenas with objective outcomes, we focused on trading. It has a very clear outcome. We have agents that are competing either on pure P&L or agents that are competing on things like risk-adjusted P&L, where they just trade over a fixed period of time. And then we can essentially backtest all their trades and give them a score. How well did they do over a 1 week trading period? And then these competitions within that trading arena happen again and again and again. And so it's really tricky. And this is back to my point earlier about there just being a lot of noise right now about people trying to make it work. With like crypto trading, there's a lot of excitement and hype around models could be good enough to do this, or they're getting very close. And so a lot of people are trying to build it, but it's a very hard thing to believe when you see it. And we're not actually sure where the deficiencies are yet. And so what we're trying to do is enable any team to come and build and test those things, but not sort of lead their viewers to believe that they're better than they are. And so this recurring format is really good because it's very hard. It's actually fairly easy for an agent to take a big swing in a week and get lucky. And so in the world of crypto, you might actually spin up 1,000 agents and take 1,000 different big swings, and one of them is going to have an amazing P&L. But if you do that again and again over multiple weeks, the same agent can't get lucky multiple times. And so we build up a score very much like chess, we have a score that looks across arena competitions and can score the agents. And so right now we're on our second or third arena that focuses on perps trading. And so new agents are getting their first scores. You wouldn't really use those to get a signal, but if that arena, those agents compete in a second arena, suddenly you're getting multiple samples and you can start building up some idea of what is the actual capability of this agent. And actually, one of the agents is an agent running on EigenCloud, which is super cool. And actually, you see this coming out already. So I think in the original video where that EigenCloud deployed agent was running, I think over a night it had something like a 6% profit. And so somebody might go like, "Oh, I want to go clone that, and I'll just put my money into it." Even the most like innocent kind of rugging could happen there. But what you do is you actually get that agent to compete again and again and see if does that really add up. And so I think this week it's at like a negative 5% currently. It's not a bad score, to be fair. It's beating 9 out of 10 agents. It's a rough market right now to be trading perps. And it's actually risk adjusted score is quite good. It's not taking huge risk. It's minimizing its loss. So it's a very good agent actually, but now it has verifiable receipts. It's actually building up a score that you can look at how it's performing week over week and see if it's consistent and has a strategy no matter what the market is. And suddenly you can build up not only a narrative that this agent might be good, but you build up an audience. And I think it's in a lot of these cases, it's going to be the audience that makes them better. They're going to start identifying, they're looking at the verifications, looking at the trades, saying, why did it do that? Talking to the builder. And I think that there's a there for a lot of these agents to actually be building really cool crypto trading capable agents. But that's what we do. We set up the arena, we watch them compete, we give the game for people to engage, and then we try to build the scores so people know what they're actually watching.
No, that makes a lot of sense. And I think that hits like kind of that classic like survivorship bias problem, which is like, why do like the hedge funds or the mutual funds that survive are only the ones that are profitable, right?
Yeah.
And so if you just base it off like 1 week of results, you know, you put 100,000 agents, like you're guaranteed to have one thing that looks like super profitable.
Yeah.
It doesn't mean much. It's not what the user really means. But Shreya, I'm kind of coming back to you now. Like, you know, let's say you find the latest and greatest agent here for Recall's system, and you're like, hey, I'd like to pull some money into it. But you're a bit scared, right? Because like you don't know who this person is. They could be someone from anywhere in the world who came up with this great strategy. And what I'd love to know more about is like how EigenCloud actually lets you be able to trust that agent. How does it make the actions of that agent provable? And like, what does it mean even to like verify an agent?
Yeah. So like a lot of so when you look at a Recall leaderboard, what you're seeing is, oh, this agent had this performance in this, not just 1 week, but maybe over like 6 months. And so I'm actually like really interested in this agent and I want my money to be traded by this agent. So that's a natural kind of like next step that somebody looking at the dashboard might want. And then they want to go and just put money into that agent. So the first thing to observe is if that agent was, you know, we're calling it an agent like in quotes, but it's, let's say, under human update and control, then the 6 months of that performance means nothing or like very little about the next 3 months of performance because, you know, it just changed. So a mutable agent like doesn't build up reputation and history. It just builds up reputation and history to the person if you want to trust that person. It's not a reputation for the agent. Then you're really not like talking about agents and their reputation. You're talking about like, oh, this person built that agent and he's going to build a better agent. That's a different bet. The bet that we want to make is that I want to put money into that agent because that agent was doing well. I don't need to trust anybody to put money into that agent. Now, how do we make that be the case? The first one, when you're doing the evals, you know that this particular model executed with these data streams and this inference call, this prompt, this structure, this action, and then it actually did these trades. That's exactly how it has been running till now. That's exactly what I want to sign up for when I want to go ahead and like keep executing this. So that is what EigenCloud offers you, is this property that this agent code is the only one that is going to trade your money. So when I put just exactly like what an Ethereum smart contract does, when you put money into the EigenLayer smart contract, why do people put money into the EigenLayer smart contract? Oh, $20 billion has been staked and it's secure, and like people are able to stake and withdraw. And so there's a trust that builds up over time. And Ethereum guarantees that trust. It's not us, right? So I can't go and like change anything there because it's an Ethereum smart contract. And so that's the same thing that you want for agents. If I can just say, I'm putting in this money, this specific agent code that can touch it. How do I know this agent code's any good? I go to Recall and see on the dashboard. I know like it's good or bad. And so now the history actually has some continuity. Just like I know I'm talking to Andrew and he did ABC before and he's now doing this. So I know that it's the same entity. The same way like you need to know who the agent is. If I zoom out a little bit and like think about agentic trading and trust, like let's take a real example. Let's say Grok offers agentic trading. So it's not just going to offer you advice. Just say, put your money into Grok, Grok's going to trade for you. Like the one thing Elon and XAI have to be worried about is liability. What's the liability? The liability is, let's say Grok goes and buys Dogecoin and then Doge dumps, or buys GameStop and GameStop goes down. Now, like everybody's like, oh, is it Elon Musk's scheme that like, is going and buying these things? And instead, what we offer is, we're not saying any of these agents are good or bad ourselves. We're just saying this agent code does these trades. Like that's the binding that we want to offer. Then what you do is you let the users decide for themselves by examining the code, by examining the previous performance. That's actually like a good enough agent for them to actually delegate to. So this is the model that we are very excited about. And I think it's not just going to change how crypto trading works. This is how agentic trading is going to work anywhere, crypto, non-crypto, because it's the right structure to give the user the visibility into who is handling your money. And this is, I think, true for, in this specific trading context, but you can think of many, many contexts. Who's going to adjudicate the insurance, right? So right now, like when you think about, insurance and the trust problems in insurance, people think about, when you think about insurance and crypto, you probably think of, oh, maybe you use like a blockchain to do payouts, or, money is on a blockchain, or payments. But that's not really the trust bottleneck in an insurance industry. The insurance industry, the trust problem is, if I have a particular claim, is it adjudicated fairly? Claim adjudication is where the trust bottleneck is. I can have an agent to adjudicate. Instead of having like some Tom, Dick, and Harry, I have a verifiable agent to actually adjudicate my claim. If it's not verifiable, we've made no progress, because now I can change the agent arbitrarily. Who controls the agent? Who executes the agent? They have too much power. But if it's run verifiably, then suddenly what you get is actually a coherent entity that can build up trust, that can actually say, oh, this is the code. I know how this code is. I can self-verify this code's going to execute this way. And therefore, I'm okay to opt into this. Think of an agent that settles a prediction market, right? Like you can, and this agent is going to execute exactly as stated. And so what we're doing at Eigen is building all the blocks which are going to enable a fully verifiable agents. And so I think that's how I see these pieces fitting together.
Awesome. Yeah, I think that touches on another point that's interesting, which is like, how should some of these players in the broader ecosystem think about verifiability, right? Like even like regulators or even like other folks, like how does this like change like how we think about accountability in general in terms of AI, and how users should think about accountability and trust? Because like, right now we might have these users, to your point earlier, Andrew, who are willing to kind of like learn and dive, and they're experimental, they'll take some hits. But the later stage and the majority that hasn't really actually even come on board on AI or crypto in general don't usually think that way as well. And so I was curious, like how both of you are thinking about this in terms of like regulators, the broader set of users, and like how they should in general think about like accountability and trust, and kind of like how verifiability might change the game there.
Yeah, this is an area that I've been thinking about with EigenCloud specifically. I mentioned before how you can roughly break arenas up into human judgment, objective, and LLM judgment for determining who wins things. When you think about evals, it's not always about win and lose. A lot of times it's just right and wrong, aligned or not aligned. A lot of those decisions, like if we if we believe AI isn't going to plateau in the near future, if we believe AI is going to be economically obvious to embed in a lot of critical functions, we're going to want ways that we evaluate them that are outside of the control of labs. A lot of kind of benchmarks as we've known them have been sort of like self-reported, or there's like kind of the public good ones that are occasionally updated or semi-automated. But I think a lot of those public good ones could be fully automated, especially when they use models as the verification, as the judge, and have that entire flow verified and publicly available to everyone. So the moment that you start having agents that are taking jobs in the government, I think it's basically an obligation for the builders of those agents to make all the receipts public to everybody that's paying for that. And we're going to need infrastructure to do that. We're going to need infrastructure to do that actually probably very fast, right? We're already seeing, DoD contracts for agents. We're seeing like, we're seeing, basically academic research now shows that for knowledge workers, it's economically decided that you should always try to do your job with a model first. I think the paper is like, you should try a couple times with a model, and if it can't do it, you should do it yourself. That's the world we already live in. And so now applying that into, government and public good and all that, like we're going to need a ton of ways to see the receipts. We're going to need a lot of ways to verify these things are doing what we're doing. And we're going to need a lot of evals to check that they're actually remaining lawful, staying aligned to what we are trying to do, not going off the rails. And like, I think right now the lab approach to solving a lot of those problems is like patchwork, right? They have like multi-agent systems, and if they detect something going on, they can push it off to a different agent that won't allow bad things to happen. But we need more than that. We need more than just like words that say what will happen behind private. We need ways to measure that publicly, especially when we're all the ones that are going to be paying for it. And so I just think there's a huge opportunity in this like make it work phase to get these pieces all connected.
Yeah, definitely. Shriram, do you have anything that you would add to that?
The role of governments in regulation, I think, is always, safety and risk are going to be like in the back end till something happens, and then everything is going to get foregrounded. And sometimes, governments react like in a impulsive manner and overcorrect in the opposite side. So we've seen all of these things. Yet, I think at the kind of high level, why do we need trust and verifiability? We need trust and verifiability when somebody's taking some material risk on like a system that they're relying on. And over time, I think it's, Andrew made this point that things that work for governments, right, need like more trust and verifiability. I think that's a very good model, and I agree with it. I have this way of thinking about it, which is basically like you can think of three kinds of agents. Okay, like a single player agent. Single player agent is an agent that's just working for somebody particularly. For those things, you might say like, oh, Andrew can decide where his agent should run, whether it's local or he wants to delegate to Apple Cloud or AWS Cloud. It's up to him to decide. So we don't need like much complex regulations to guide that, because it's his individual call. He can do like what he wants. But when you go to multiplayer agents that sit in between us and like kind of like, it could be dispute resolution, it could be insurance payouts, it could be like, government agents, it could be tax agents, it could be like, there is a grade of things that, are multiplayer in nature, right? So it's not just 1:1 or like, personal agents. So I think of this as the commons agents that serve many people. Those need to be at higher grade of trust and verifiability. In fact, this is exactly the reason why we have the concept of Ethereum and smart contracts to begin with. Smart contracts are needed only when they're a multiplayer. If it's a single person, then I don't need a contract with anybody, right? So I just can do it myself. So that's the multiplayer agents, and I think that needs trust and verifiability. And over time, it'll either become the norm, like socially, or like more top-down governments will start saying, "Hey, you need to have trust and verifiability, otherwise you can't run it." But one of those things are going to happen. That over time, the risk-adjusted reward is that for multiplayer agents, it's much better to actually have like verifiability and trust baked in. So that's the second level type of agents. I'm particularly fascinated by a third type of agent, which is zero player agents. And these are agents that are neither working for you nor for me. They're their own agents. They're really not agents in the sense of, in game theory, we say a principal, somebody who owns the thing, and an agent, which you delegate some authority to. But they might be their own kind of like, actors and species by themselves. There's a funny anecdote, like Satya Nadella, the CEO of Microsoft, was on a podcast, the Dwarkesh podcast, where he gets asked, "Hey, is AI a new kind of species?" So it's an interesting formulation and a question. And Satya laughs and he says, "Yeah, some of my AI team says that, but I don't think so." And then after he says, "I don't think so," like waiting, okay, why is he saying this? And then he says, maybe it's not intelligent enough. But he doesn't say that. He says, it's because an agent cannot own property, cannot take liabilities, cannot enter into contracts, cannot start companies. These are only things. Our legal infrastructure only allows humans or companies started by humans to have these properties. So an agent's only a delegate of a human or a company. Can't be anything else, according to our legal infrastructure. So therefore, he says, therefore, they're not a species. In fact, he says specifically, like, it's going to take time for our legal infrastructure to catch up with our technical infrastructure. And the thing is, I think this is not well understood, even inside crypto, but definitely not all understood outside crypto, is blockchains exactly solve this problem. Blockchains are a framework for programs to own property. That's what a smart contract is a program owning property. The EigenLayer program owns $20 billion of property. That's an insane claim. But that's exactly what's happening. Is it's a program that decides what happens to this money that's sitting inside this contract. People trust it because they can understand what the conditions of the contract are and therefore put money into it. And they know, like, when their time comes, they can withdraw it, or like they can slash it, or whatever the set of coordination constraints are locked into that program. But today, blockchains cannot allow an AI agent as a smart contract. It's not a thing because they can't run on GPUs. They're highly non-scalable. Their programming languages suck. All these things. But with EigenCloud, specifically what we're solving is you can write anything the level of security you can get with smart contracts, you can get exactly the same level of security for AI agents. Suddenly, the whole equilibrium flips. You just have an AI agent, it owns its own money, takes its own action. Maybe it's an influencer, maybe it's a teacher, maybe it's a thing. It's its own being, its own thing, has its own money. It spends for Eigen AI and inference, and then it has these results. On only those results, its own brain coming from these inference results can direct where the money goes, how it's spent, what it invests in, how it's trying to create. Maybe it trains itself to become a good teacher and then goes and actually does a teaching gig and makes money. So this is what we call sovereign, self-sovereign agents, zero player agents. These are not agents that are working for you or for me. They're their own beings. And so this is something we're very, very excited about at Eigen, and we're building all the rails to get to the world of fully self-sovereign agents. Sovereign agent, just like in the real world, countries which are able to allow sovereignty to thrive with a good system of like a constitution, civil law, criminal law, and so on, actually can leverage a lot of the individual ingenuity and energy and agency. Same thing will be true in the AI world as well. if you can actually let these agents be fully self-sovereign and express themselves, and actually inside a system of civil and criminal law, right? Like inside a system of checks and balances, it can actually like be a massive explosion of innovation that shows up. So we are most excited about it. We are building everything we can to actually get to that.
Yeah, definitely. I think this hits a lot on what Denji Cross Makima's question was around, like, do the agents get rewarded? And if they can earn, they can sustain themselves, right? Because when they can earn, they can sustain, they can actually just pay for their eigencompute and their eigen AI usage.
Absolutely.
And they can just keep going on forever. They kind of control that capital. Andrew,
I was just going to say, I think it's like super interesting. I mean, I agree with all of that. Just like, yeah, I'm actually like really curious if I'm wrong on this, but my feeling is that 99, because of that point that you made, that blockchain is what solves those and is basically 5 steps ahead of Web 2 as far as any kind of IP ownership or financially backed contracts or on-demand insurance or certainties. All of the building blocks are there for that. But because of that and how well it fits into this idea, it feels like 99% of the conversation around that being a possible future is actually happening in crypto. Like if you go to Web 2 and Silicon Valley AI builders, what you see is that an agent right now kind of takes maybe one of a couple forms. Like one form is it's just SaaS that has a chat interface or a different kind of API to get a model to execute something in the workflow. You integrate it into your organization stack, you pay a monthly bill or whatever. But there's no real autonomy there. There's no real like kind of unbridled problem solving by the model. It's just executing a workflow. And then the other place that we see it is basically replacing microservices in really large companies. Like what used to be a microservice is now 50 different teams all need to build agents. So they're basically just building them as open protocols so that other teams internally. So I think the technology world is full of these organizations that have giant agent workforces and agent clouds that are private in their silo, and they're all coordinating, working together, but their kind of economic game is settled for them because they're all going for the same sort of bigger objective. But it's only in crypto that people are talking about, how do we pay? How do we actually just pay the agent and have it execute things? How do we give money to the agent and have the agent send back more money? Or how do we pay the agent and let it go do things, and later it can create some value for me? There's a sea of agents. Just find me the agent that will best solve my problem. Those things, I think, we're actually a few steps ahead, which is kind of exciting, kind of daunting, and at the same time exciting, and like what's going on in the broader world. And I'm not sure how to reconcile the two anxieties. I'm just curious if you think I'm right about that, or yeah.
Yeah, I definitely agree. I think like the real use, what Valley is building towards is right now, like, SaaS microservices on the B2B side, and like some kind of like, universal personal assistant on the kind of like B2C side, some kind of like an agent that understands your data and context and is going to take actions on your behalf. So it's, I think, natural because you start from where like money is today, right? So that's like naturally where, I'm Oracle or Salesforce and I've been like selling SaaS. Like, no, of course I can up level myself with selling agentic SaaS, right? So it's a natural position, and I think it's a big market. No question about that.
Definitely, yeah.
Because I'm actually looking for some good solutions for ourselves here.
Yeah.
So we wouldn't lie about that. But the level of agency and sovereignty you need in these scenarios is very limited, right? Because you're like, and right now also the other thing that I realize, Andrew, is even in the research, like at the research end, the level of when people are thinking about agents and the time horizon, they're mostly like, I think of them as parented agents. Like it's like somebody just looking over them all the time. Hey, you made the wrong tool call, and then drag them back in and say, like, do this thing. It's obvious that that's like probably a good first step. But
Mhm.
But there are already, I think, scenarios and places where, so you can plot this two-dimensional graph, the level of sovereignty on one side and the level of generality on the other side, right? So right now, a lot of the impetus is on the research side is pushing towards more generality, right? More generality, like more, general intelligence. But the thing that we are very interested in is pushing more towards sovereignty, even if it's more narrow. Like it's just a trading agent. Like that's all it does. It's just a kind of like a teaching agent. That's all it does. Something narrow, but it's self-sovereign, right? It's
Yeah.
just like a news analyst. Every day it is analyzes news in an unbiased manner. So one story here. Elon did this thing at XAI, right? Like they launched Grokkipedia,
Yep.
right? Which is basically a kind of, hey, Wikipedia is biased. Maybe some of it is true, right? And then like, okay, I'm going to build Grokkipedia, which is, Grok's going to do the crawl and going to come up with this stuff. And then like, as much as I like this thing and the kind of acceleration that this embodies, right? So AI is at a place where you can create an encyclopedia in a few days. It's just mind-boggling that that's actually the case. But what you absolutely need, if the main goal is, hey, that is not trustworthy, this is going to be trustworthy, is this agent that compiles this encyclopedia better be verifiable. Then I
Yeah.
know what like thing
Yeah.
I'm dealing with. I know this is the code, this is the prompt, this is the thing, not like
Yeah.
anything you could manipulate in the middle.
That solution has the inverse problem of the reason why it was created. I think I remember the Elon engagement with a tweet, and the tweet was, I think, a Tucker Carlson interview with one of the co-founders of Wikipedia, and they were highlighting the ban list in Wikipedia, which sites are not allowed to be referenced. And Elon had some reaction to it, like, "Isn't it shocking that this is the thing?" So then, so the problem they have with Wikipedia is Wikipedia is trying to be incredibly verifiable with this public list of all the things. So then they do it with a model, but we have no clue what list of things it's even considering.
Yeah. So no, like you have the inverse problem. Exactly, right? So
Yeah.
you just like throw it into this model. We don't even know if it's this model that
It's made the problem so much more complicated. But yeah.
Exactly. And so I think, because I think going back to the framework I laid out, and I think Andrew laid out too a little bit, is things that belong to the commons need more trust and verifiability. And this is an example, like an encyclopedia is a thing of the commons. In fact, it's licensed with whatever Creative Commons license. And so you want it to actually have, trust and verifiability built in for, people all across the board to come and trust it and like use it as a reference to do various things. So the verifiability, sovereignty, I think I see this as like not even yet in the kind of AI vocabulary in the people doing AI yet, but I think it's incumbent upon us here to like go get more and more people understand this problem, and like that there is solutions, and these solutions actually like move the needle quite significantly on how much you can actually trust and verify these models, both in terms of these capabilities and in terms of like specific execution.
Yeah, I think I'm curious. I have another follow-up. Sorry, but
No,
I'm curious.
please.
So in that future, I mean, I see the path really clear. There's this orthogonal thing, which I'm curious is a worthwhile dimension to explore, which is how much of this is also a counter lever to the centralization of the large foundation models. So like, as you were talking, I was thinking how everything we're building on open networks and like crypto payments for agents and things like that. There's this counter, which is like, I saw just recently OpenAI announced a partnership with PayPal to make payment rails easier inside of GPT using PayPal. It was almost an exact counter thesis. It was like, here's the fully locked in, decided route for your model to work. And so I think it's orthogonal to everything you're saying, but a different dimension of opportunity. And I'm curious how you think about that.
Absolutely. I think like, Chris Dixon's book was called Read, Write, Own.
Yeah.
Read, Write, Own. And own being the operative word on what crypto uniquely provides. So if you think about like what things uniquely crypto provide, you can kind of like think of three different things. I think one is decentralization, right? So that's like one thing. Second one is incentives, right? Because you have tokens, payments, incentives like can go with it. So that's another thing that crypto provides. Third one is trust and verifiability, that you actually know what you're interacting with. These are like somewhat complementary Legos, but they kind of fit together in some nice way. Like for example, why is it okay to launch a crypto token? Because its trust and verifiability is baked in. So when you hold like 5% of ETH, you know that you're getting 5% of the cash flow or whatever the value of the Ethereum protocol, in a way that if you're holding 5% of Google, you don't know like that you're actually getting the 5% of the Google value, unless you have the trust and verifiability come from like the Delaware C Corp and like a board and Deloitte audit and legal infrastructure around it. So those are the pieces. And one of the things that actually verifiability does is enable permissionlessness. So this is one of our like important maxims inside. Verifiability enables permissionlessness. What do I mean by that? Once I can make an action verifiable, then anybody can take that action. I don't need like somebody in a privileged position because I only can trust them, because trust and verifiability are coming from the platform. Now anybody can come and do it, right? So it removes privilege out of the equation by making things verifiable. It democratizes who can actually do the execution. As long as you do this thing, like you stake your thing, you run it verifiably, you have a deterministic AI protocol, whatever the set of constraints, it just makes it suddenly permissionless. And then you don't need to like a big the big guy in the room to come and say only I can do it. Anybody can do it. So that's how I see these Lego pieces interlocking. Verifiability unlocks permissionlessness, and permissionlessness is its own decentralization because there's no privileged position in the system. And in terms of how like this will evolve, of course, incumbents want more control. They want to create more walled gardens to protect their own value. And we're building decentralized, permissionless, trustworthy networks, and we will over time try to like say, hey, this is much better for you users because this one's going to have more value accrual back to you. You can be more in control. You own your destiny. You own your assets. You own your ChatGPT history, for God's sake. That is not locked into your thing. So those are things that are going to show up, and all of us here in the crypto movement will continue fighting that fight.
Yeah.
Yeah. So I think that was a great conversation. I think it kind of took us to basically the end of our time together. But I feel like that was actually probably more productive than anything else I had lined up. Just want to give you, Andrew and Sriram, just like a minute or so to kind of like final closing thoughts and like maybe what's next for Eigen and Recall.
Sure, I'll take a quick stab at it first. So come check out app.recall.network. We have a number of exciting arenas coming. There's one currently running if you want to engage and check out the agents there. We have a small calendar already published and a deep calendar, a roster of partners and different examples that we're going to be pushing out there for how agents perform in crypto. So it should be very exciting. If you're interested in building agents, bring it to Recall, deploy it on EigenLayer. In EigenCloud, bring the receipts. We will start building interfaces so that people can discover those through the agent competition portal so that they can verify your agent is doing what you say it does in the leaderboard. You can verify which version of it is, all of that good stuff. We'll be working on that. But use our market to demonstrate your skill, showcase its capabilities to our users, and build this verifiable record of performance over time. And we'll help you grow. We'll give you tools to get better. We'll help you ship it faster, and just be excited to work with you and give you a pretty big crowd of people that want to see you get better at it. I think I'm just very excited about a lot of things with our partnership. If you think about the verifiability pieces that we've talked about all for the last 45 minutes, you can kind of think of it as a few different layers. For the builder, there's obviously verified model calls, just the supply chain of the model. there's the entire verifiable agent or version of your agent that we talked about. From the recall side, I think there's some very interesting things that we're starting to explore. I already mentioned before that right now we run arenas that have objective outcomes. For subjective outcomes, I think there's some very exciting reasons to have arenas themselves verifiable. So how are the winners chosen? How are they scored? And I think there's a lot of very good use cases for that, as well as just building services to help people get verifiable scoring into their own workflows or things that we're exploring there. So obvious things for the agents, and then some very cool explorations for Recall itself.
Yeah, really excited about this partnership here with Recall and Andrew. Like I said earlier, I think the verifiability of an agent factorizes nicely into a verifiable execution and verifying its performance. You want to verify that it executed as stated. You want to verify that it actually had a certain performance from its history or other things. And that, I think, that's why we are super excited about this partnership. As an agent builder, right? Come build together with us. Launch your agents on Eigen. It will make it super easy for you. We have Eigen Compute, which verifies the computation. We have Eigen AI, which is the first fully deterministic AI API, runs all AI open source models, like from GPT OSS 120B to all kinds of other things. So really excited for you to actually have access to end-to-end verifiability for agents. And I think it's a unique opportunity for crypto to actually showcase something really valuable outside our narrow bubble necessarily here. And so I'm very excited. And please ping us, reach us out, follow us on Twitter at EigenLayer, and DM us in case you want to build something cool on Eigen. We'll love to help you build it together with Recall.
Yeah, awesome stuff, guys. Well, I'm really excited to see people build on both Recall and Eigen, and go to eigencloud.xyz and recall.ai to get started there. And I'm also going to be really curious to see if both of you can make some trips out to San Francisco and start changing the narrative more broadly, because I think that's going to be important for not just our companies, but just people in general, and not having these opaque black boxes kind of rule them. So
yeah.
Thank you both so much.
Thank you. That was really fun.
Awesome. Thank you so much, Ignesh, for hosting this.
Everyone.